You're asking me a question like that for probably the 450,000th time you've asked that to me in here. Does light, but you have your, I don't want to be insulting, but it's kind of a script in a way. It's maybe just what you do, but I'm not trying to say you're reading a script from some whatever, but you say, does it been through this? What?
It's because I never get a satisfactory answer. The obvious answer, the correct answer is yes, light bends. It's been demonstrated 1 trillion times.
Right, but I'm just going into, I don't, light itself doesn't bend, but that's fine. We don't have to, if you want to say the path of it is distorting through the environment and going off of a straight line, I hear you, but just that the phrase light bends is not something I agree with, just in general.
Okay, so the path that the laser light takes through a sugar water tank is a curve?
No, it's, well, okay, yeah, you could maybe say that. The path it takes, the propagation path coordinate, the propagation coordinate path of it would be a curved path, if you want to say that. I'm not claiming it is or isn't. You're claiming that. I'm just saying in terms of that. But what would actually be happening is that the laser light is moving in straight lines, getting refracted off the sugar, and then bending down to, so it's like straight lines, straight lines. They're all straight lines being bent. Or not being bent, but being refracted or whatever.
Yeah, I 100% agree that at a molecular level, like between molecules, it's straight. In fact, I have a little meme. Let me find a meme, one sec. Do I have a meme? Probably.
But I don't think you can just, I mean, even if light can make that path in different gradients, it's just not valid. I think you know it's not valid, which is why you're kind of still on this in a way. Like, no offense, but I'm just saying you're still on this.
You wouldn't be calling me a liar, Gio, would you?
No, I'm not saying you're lying. Why would you say that?
Well, you kind of implied that I'm not telling the truth. I know it's not real. I know it's wrong.
Well, maybe that was a little bit more. I'm not trying to call you a liar, like that you're consciously, because I mean, the human mind is complex and there's a lot of layers to things. So, I mean, I'm just saying for like a man to be coming into a Discord where people are talking about the Earth being stationary and planar and so on, for like, I don't, it's fine, dude. You don't like the psychoanalyzing. It's often where I go because like you're just doing the same thing. So I'm always just like, dude, you're doing this thing.
It's interesting.
But
like I could say, oh, Gio, like he spends like 20 hours a day in Discord. What's his life like, right?
I don't spend 20 hours a day in here at all. I'm on here for a few hours a day. Sometimes I do a little bit of a stint, but no, I mean, just because my account's in here doesn't mean I'm always here. I kind of leave it in as I'm running around doing stuff. So no, I'm not on here nearly that. Right. I am listening though. I mean, I am listening, so I'm often listening, but I'm doing all kinds of other stuff. So I'm not just only doing here, but no, but it's not really the same though, because I mean, in whatever the case is, like those of us spending time here talking about it, I'm just saying like you're coming with the same thing, and it just seems like, I mean, how confident can you be? I guess that's more where I was going with it. Like, how confident could you be in the globe model if you're coming here every day with this kind of thing that doesn't really ever, you know, sit, like it doesn't ever seem to do what you want it to do, which I guess is for people to go, oh, Roohif, you're right. Oh my gosh, you know, you're right this whole time. Like, I guess.
See the right-hand side of the screen where it says Roohif Noel playing Balatro?
It might be on your screen, but I can click your name and see that you're playing a game. Yeah.
Right. This is my chill out time, do whatever the fuck I want time before I go and make some dinner.
No, it's all good, dude. We don't have to go into the whole psychoanalyzing thing. I just mentioned it because when I said you must know that there's something off about it. Because well, it's sort of like this. It's sort of like like somebody who, like, I don't know, man. I mean, if I went into a place where they're talking about, you know, the old like pigs can fly example, and I go in there, and if I lay down to them like, okay, pigs can't fly because they don't have wings, they don't have this, they don't have enough wing to support their weight, they don't, all that stuff, you know, and I was doing that year after year, I would definitely psychoanalyze myself and be like, okay, I must have a conflict here. Like, I'm going to these people who totally are not being converted by what I'm saying. Although there is an audience, and so people are hearing, so I hear you on that, if that's what you're thinking too. But, and I guess if you have an agenda, but I'm just saying, like, I would analyze myself and say, okay, what is going on with me to where I feel like I have to go and tell these people this thing, oh, you know, in this way, you know, and just tell them they're totally wrong about the thing they're thinking. It implies some kind of a conflict, but that's fine. We don't have to. We don't have to go into all that if you don't want.
It is a strange way of having fun, that's for sure.
Strange to be a flat earther? Like, again,
No,
we're just
no,
saying people are
it's
weird.
strange to be an anti-flat earther and come
Strange
into
flat earther.
flat earth rooms and
All
debate
flat
it.
earthers are retards.
Right. So
Yeah.
you do know why refraction is like a null and void point on the celestial theodolite. Do you understand why the flat earthers are saying that?
I understand why they claim it. Yeah, I'll give you an hour, buddy.
Okay. So what I'd like to hear why that is. Why does refraction not play a part in it?
They
I like how
claim
that all just finished with Roohif just throwing a hard R, just a hard R at it. That
Yeah.
shows the level of
Oh,
mental
yeah.
condition, dude. You're coming to beat up on retards, is what you just
Oh, no,
said.
it's
That's what you
again.
think. That's what you think you're doing. You aren't
Yep.
actually doing that, but you think you're doing.
Okay.
What kind of person goes into a classroom full of Down syndrome kids and just dunks on them like in basketball? You know, it's like that's what you're trying to do, dude, and you're not
Yeah,
even good at it.
Do you want to
yeah,
do
and
this?
you're not getting any conversions, and I mean I have more education than you do.
Do we want to? Hang on. What's
So you're gonna call me that, and I have more education than you? I have a master's degree from a fully accredited college, grad
Is it
school in the
though?
United States. Yes, it is fully accredited, the same accreditation that accredits Harvard and Stanford, and yes, every college in the west part of the United States. Yes, it is fully accredited. It doesn't matter. I'm not trying to like say that. I'm just saying you're gonna say come and call us that, even though I have more education than you do. So I'm just saying, I'm not trying to one up you. I'm just saying it's pretty twisted to say that.
Anyway, the question was, do I know why they say that refraction is excluded? Yes, they claim to have a 50.7 kilometer long theodolite because they're pointed at the crosshairs at the mountain.
Right. So, do you know why that matters?
It's wrong because you're looking through 50 kilometers of atmosphere to point your crosshairs at the mountain.
Right. So, listen, it's about the physicality of the time that the star gets occluded, meaning that that mountain, if it were on a globe, that mountain would be tilted away from you because of the shape of the Earth. And it's
Okay.
not. It
How do
has
you know it's
nothing
not?
to do with refraction. It's the physical shape of the object occluding the star. So if
Okay,
it,
how much?
just like we don't see buildings leaning away from us, we don't see like in the distance they're
Hang on.
straight, parallel, up and down, perpendicular, whatever. You know, it's the actual angle of the mountain is right where it's supposed to be on a flat Earth.
Hold on.
So
Slow down. Slow down. Okay, how much is a mountain 50 kilometers away tilted back on the globe, hypothetically?
I have no idea. I haven't done the math. I just know that it's about the physical timing of the star being occluded. It has nothing. It's about the physical thing happening. It has nothing to do with refraction. So if you're invoking refraction, and look, I'm not taking sides here. I'm saying I'm trying to articulate the point of the flat earthers because that is the point that it has to do with the physical timing of the star being occluded by the mountain. And if it were a globe, it would be
Yeah,
different.
keep
And
We
going.
get
Keep
but
going.
if you're invoking refraction, you're already missing the point.
Okay, so you finished your gallop. I'll address the first point. The Earth curves, the amount of Earth curve is 1 degree per 69 miles or 1 degree per 111 kilometers. So that mountain is tilted back by half a degree. Do you have any idea how much that would change the height of the mountain?
No, I don't really care. That's not
Why did you say
like
it? Then why did you say it?
because if you're invoking refraction, you're missing their argument. Like
Hold on. Okay, so I'll
so
tell you
you're
that
talking
the
about arc
height.
seconds anyways, right? You're
Hang on,
talking about
hang
arc
on,
seconds. So
hang on. We're
that it
addressing
wouldn't
the tilt
surprise me.
first. All right, we're addressing the tilt first.
No, I'm
Change.
not
Yes, we
actually.
are.
I
The
don't
change
care
in
to
height is
argue or engage with you. I'm just
98.99
trying to
okay.
make that point to you. I'm gonna go
Can I
because
can I
yeah.
ask a Roohif a question? Just how much later do you think that the globe should occlude the star? Like in seconds, is in time.
Yep,
Like we
one
both
second.
concede that the star's going to be occluded. What's the difference in time between globe and
Okay.
flat?
I'll answer that in 10 seconds. The amount of height that the mountain changes by with half a degree tilt is 0.01%. Okay, 1/100th of 1%. Rick, the mountain will occlude at 6:27:25 exactly as it did on the globe.
No. The
Yes.
prediction of the time difference between the observation,
Yes.
not the time
6:27:25.
specifically of when it would occlude on the. Are you saying that that's the exact same time
That matches the
as
globe.
FE?
Well, I would say it doesn't match FE, but that's because they're doing that stupid shit, right, of moving the observer and turning refraction off. But like I said the other day,
I want to know if it's like a minute later or 10 seconds later. You know what I'm saying?
so
That's kind of the thing I'm looking for.
right at the time 6:27:25, at the time it got occluded, the predicted angle to the mountain was 2 degrees 19 minutes. The predicted angle to the star was 2 degrees 18.5 minutes, and the measured angle to the mountain with the theodolite was 2 degrees 18. Globe predictions confirmed.
Yeah, you can roll that in there if you like, bro. But I'm just asking the question, eh? Like,
Yeah.
I think I got to get that figure somewhere. So you say it's the same time?
Yeah. I'm happy that it got occluded at 6:27:25.
Gotcha. Radio. That may actually not even be part of the argument. I'm just kind of curious if we would expect to see a difference.
That's
No,
not true,
and
Roohif.
that's
You're
what
never
Alan
happy, dude. That
Alan
you're not
claims.
happy. You're never happy. That's a
Alan
lie.
claims that the globe would happen at a different time. He is wrong.
Who said? You say Alan said that?
Yeah, Alan and Shane claim that it should happen on a globe at a different time, and they're wrong. They're still straw manning. Shit.
You would say that
Why?
it would happen at the same time, exactly down to the second.
Oh, down to this. It depends on what the actual angle to the mountain is. Like I said, the prediction is 219 and was measured at 218. The prediction for the star was 218.5. So, right in the middle. But then you could say, oh, the mountain will appear higher during the night and lower during the day. So, it's 30 arc seconds off, which is not very much.
I don't know. I recall that gentleman who seafoam with his pretty professional looking equipment, right? Like sort of zoomed in on the moon. And I know the moon moves a little bit faster, and he was having to sort of track it. He was so zoomed in that I think he had to adjust every sort of 5-10 seconds or something. It was getting a bit annoying. So
With
that
an
implies
EQ
then
mount?
stars move that much slower. I don't know. I'm obviously going to have to go do this. I've been playing around with the P1000, but yeah, I'll be on
Yeah,
this pretty soon.
on my EQ mount has a lunar tracking mode and a stellar tracking mode, and a solar tracking rate as well.
Yeah, he had all that stuff, but it malfunctioned, and so whatever. Yeah, cool.
Yeah.
I've spent enough money on observational equipment for now. I'll let this get me a little bit more excited before I start throwing in more cash, like tracking beams and shit into it.
Yeah, I've only got a 10-second clip of me tracking the moon for an ISS transit, but you'll see the moon doesn't move. Give me a sec. And I shall post it in the chat. Boom. There you go. Yeah, so it's only like 10 seconds, but the moon is tracking incredibly well. pew. See the ISS fly across. Pew, pew, pew. Need to sort out the camera settings better, though, for the next one. Who wants to do some partial differentials?
If I knew what they were, I'd agree.
So I had to. Were you here last night with Taylor? Talking about her.
Yeah,
paper?
so I was here for most of that.
Yeah, so I had to go.
Hey,
through
Roohif.
that paper. Yeah.
Well, sorry. Wait. Okay, go ahead. If you were right on that. Well, I was just gonna say. Go ahead. I was just thinking and then blurted out. Sorry.
I was
Just say your
going
thing.
through her paper last night, working out how. Let me share. There we go. Working out how the authors of the paper went from the refractive index formula to the refractive gradient formula. And yeah, it took me it took me a couple of hours because I haven't done partial differentials for 20 something years. But yeah, got there eventually.
That's all Greek to me.
Yeah. Well, there are Greeks in here, aren't there? Yeah, this so DNDH. That's usually a capital delta N, capital delta H, and the partial derivatives. So PD is usually the lowercase delta. But I couldn't be asked writing all the Greek shit. There you go.
So Roohif, how have you isolated that the mountain is not refracted in addition to the star? So you have two refraction. How have you isolated both mountain and star to then put this globe refraction to make it all fit, you think, a globe?
Right. So we're looking through the same atmosphere from the observer to the mountain, right, for both the star and the mountain. And then we're looking through an extra 1,000 Ks or whatever for the star. So there is 2 minutes of arc refraction, 2 arc minutes of refraction for the mountain, and I think it's 15 or something for the star.
You're just slapping on a standard on it without any actual direct measurements of any observation. You're just slapping a thing that fits globe, just 2 and 15, and call it a day.
Where do I live?
In your graphs?
Sydney. Was I in Colorado?
Yeah, so you don't have the data you need to make the claim you're making.
Okay. It's not my fucking observation, anyway.
I mean, you should at least concede to that. Be like, all right, yeah, I don't have it.
What?
Well,
I don't have it because it's not my observation.
Well, yeah, but how could you just? That's fine, but how could you? Well, but you're making an argument. You're making an argument based on it and then asserting it as the case. So, I mean, you got that
I
going,
have
but
to
you don't.
assume a standard.
Yeah, so you're just assuming a standard and just slapping it on.
Yeah.
Which involves a 3959 radius value.
No. No, it does not. We've had this conversation 50 times as well. Refraction doesn't require a globe.
What does it
Sometimes
do
we assume
without the refraction you're adding, the one you're adding? What would it be without any refraction added? What is the result?
Yeah, so the mountain would be at 2 minutes 17. Sorry, 2 degrees 17 minutes, and the star would be 2 degrees 6 minutes, I think. So that if we had no atmosphere, the star would have set, or the star would have been occluded ages before.
Ages?
Oh, however many minutes, whatever it is.
So without the refraction, those angles you just listed, what geometry of Earth do those indicate? Just from the one you listed, I'm just asking you questions. I'm not really trying to debate it. I'm just saying what Earth shape, meaning if you didn't add any refraction right now, you just took all refraction out and you did your best to just completely go, raw dog it, as if everything is just perfect physics, everything's, right there, etc. What would the geometry result?
Yeah, these are predictions, right? 217 is a globe prediction. That's without refraction on a globe.
So then what are you doing when you're adding refraction? If you're saying it's already a globe, what are you then adding refraction for?
Because we have an atmosphere. We have two things we have to account for: globe and atmosphere.
The atmosphere is the globe. That's
No,
where
it's
the
not. You
spherical
keep
geometry
conflating
is
those
involved.
two. No.
No, you're conflating them. That is what's occurring with this entire thing. The optics have a spherical component to them. The ground is flat.
In fact,
However many years
a
it'll
lot of
take you to
the,
come to that, however many years it'll take, you're on your own pace. Figure it out when you do, but that is what's occurring.
all right, I'd say most of the refraction estimations actually assume a flat atmosphere. The celestial navigation one, for example, does. What's his name? John Malencrott's the other one the other day. Kind of does. Good question, Duffy man. Good question. Exactly. Yeah, refraction does not equal globe. Because then you're saying you can't have refraction on a flat Earth. And then, I show you Skunk Bay and Black Swan. And the Earth's a globe, right?
I don't think anyone's saying that. I don't think anyone's probably ever said that there's no refraction at all. So that's not a thing.
Okay.
But if you're looking up at a mountain versus down on the ground layer, it's gonna be a little bit different. So yeah, I mean, that's why I was asking, like, do you have any actual? You don't, obviously, but like, I mean, even that 217, where are you getting that from? Just
That's the
where?
raw prediction for a globe without refraction.
Okay, but where are you getting that? Okay, but you're claiming that number is real because why? Like, why is it in reality that way? I understand if you're, in terms of the geometry, that part of it. I'm just saying, like, why would that? Why would that occur at that position? How have you isolated that it is 217 from there?
When we measure it, we're looking through an atmosphere, so we have to account for the atmosphere, which adds about 2 arc minutes. So we measure 219, but we know that 2 arc minutes is contributed by refraction. So we take that off, and it's 217 geometrically, which matches the globe.
That didn't really answer how you isolated that.
Because we know the typical structure of the atmosphere and how much it refracts light.
I mean, in a lot of ways, like all these arguments that come from, I mean, there's a lot with long distance observations and black swans and all this stuff. There's a lot of factors to all these things. But I mean, you feel like you're compelled with whatever you just said, and other people are going to feel compelled with what they just said. And it comes down to like a wiggling in the atmosphere. I'm not really saying for Alan and those guys it's wiggling because they're, I mean, I'm not really trying to steelman what they're saying. I'm just saying in general with like observations and, like this with long distances, meaning that, I mean, something is true and something isn't true of what's occurring, but it seems like within like the argumentation of it, there's just a lot of leeway, that you can, because you can basically like kind of concoct together what you've said. Alan can put together what he said. They're contradicting, and then it's like, now what? You know what I mean? No one is going to like win that per se, at least against you. I don't know if the rest of the world would care about it if other people were like, if that was added to the list of things like, oh, and also when you do a star, whether that would be the case. But it's just sort of like this wiggle room that you can always do, it seems. Any side, I guess, can always do, I guess, if you want to do that.
There is a wiggle room looking horizontally close to the surface, yes. So let's not do that. Let's get above the surface and at least look over a valley or at high elevation angles.
Why doesn't someone do this? They go up to a mountain. That would be lower, I guess. You'd have to do like a mountain that's lower, and then then do it there. Take the occlusion from altitude.
I'm not sure that would be quite.
You ever done it at night, Roohif?
Done what at night?
Sorry. Because apparently it looks more globe during the day, right?
There's usually a little bit less refraction at night, and less refraction during the day, more at night. Yeah.
And you're measuring the angles.
Yeah. So
what's the furthest distance from like the peak to a peak that you say that you've measured?
That I personally have measured, or I've seen measured? I personally, for 80 Ks, I think it was, something like that.
Okay. Did you not just say before that the measurement of the star, given the tilt away, you shouldn't be sort of like it'd be so infinitesimal? You were sort of arguing that point, were you?
Yeah, the mountain or the building, like the mountain Pikes Peak, is tilted away half a degree, and that would change its height by 0.01%, which is nothing.
So what was the point then of measuring from peak to peak?
To measure the drop, not to measure the tilt, to measure the drop.
The tilt, the drop. The point of the fact, like, weren't you criticizing the fact that the tilt away wouldn't cause enough drop? And now you're saying that, no, but 2 mountain points, right? You had a problem. You had a problem from the ground looking up to a peak, but now you're just you're saying it's completely rational to go and measure from peak to peak.
Yes. So
at like a similar distance.
Let's say we're on a flat Earth, and I'm on a mountain looking across to another mountain on a flat Earth, but that mountain just happens to be tipped back half a degree. That will not change the height of that mountain when I observe it. 0.01%. If I'm on a globe that drops away 8 inches per mile squared, I can easily measure that. And I have measured that.
How can you easily measure that?
With a theodolite.
Because of your refraction. It's all this freaking formula, bro. It's all in this formula, and it's all in your head.
I've got a question for you, right? If the atmosphere is structured like it typically is, more dense at the surface, less dense higher up, then the path of light will curve down. Cool? And we will see objects appear higher than they are geometrically. Is that cool so far?
I mean, yeah, I get what you're arguing.
Yes. Okay. So if I am looking at a mountain that is exactly the same elevation as I am, but it appears below my horizontal, and refraction has lifted it above where it geometrically is, then
that's the assumption right there. Because you're assuming it's lifted it, bro.
Okay, so you don't agree.
I don't quite know how to argue this, man, but I'm going to get there sooner or later.
Okay.
You guys and your little wonky
Yeah. See, Gio's going to accuse me of having a script now. And I'm like,
It is kind of curious that I don't understand why you sort of like you had like previously dismissed the Theodolite, the celestial one that is, for not having enough tilt, but then you think it's tilty enough at the peak from peak to peak.
no,
Is it twice as
tilt
much
is
tilt? Is that
never-
what you're claiming?
Tilt is never relevant. Never.
Tilting away.
Yeah,
Okay.
tilting is never going to be measured and never going to be relevant.
So it's the height.
Yes, the drop due to curvature, 8 inches per mile squared.
Ruthie, I think the problem is that when you say it appears higher than it actually is, I don't think that most people fully understand that.
I get it.
How about I draw it?
I just don't think you can really sort of evidence it except through this sort of wonky inference from what is it like? I think Jesse Paths of Light's experimentation, which I've heard I've heard a couple of flat earthers speak well of it. So
we do know that
I don't know how.
We do know that there's a continuous refraction downwards through a pressure density strata, don't we, over distance? We can do that in a lab, can't we?
Sure.
All right, let's draw a little curve between here.
Say through, is that like pressure, like higher density? Is that it? Like more pressure?
Not
Denser medium.
Yeah, denser medium. You can do it. You can amplify the effects in a liquid, but
what's the pressure? Sorry.
It's not so much that. It's if you've got a long enough tank of a liquid, you'll get the same effect.
What's the pressure at the ground level versus the pressure at the top of the peak? Quite often.
Hang on. Can you
that
see
you're referring to? Oh, he just said that the pressure causes the refraction. I'm just kind of curious. What causes more of the?
Well, there's a density differential between the ground and the top of the peak, isn't there?
Yes.
There's a density differential. Cool. Is that measured through the pressure?
Yeah.
Temperature and humidity. Yes.
Yeah.
Humidity now. Cool.
Density is the amount of substance in a nominally defined area, and that's a manifest of like pressure and temperature.
All right. Can you see my screen?
I didn't ask to look at your screen, man. Wait, is this going to be quick? I wasn't really hoping to be in here for too long.
It'll be quick.
Okay.
Cool. All right. So we've got the little red box on the ground
totally worth
over
it.
there.
Laser beams coming out of like cubes burning people's eyes. Okay.
So the light bouncing off this red house is taking a curved path to reach your eye.
Dude, don't draw me paint shit and then like speak to me redundancies. Is there more? There better be more to this. I'm gonna let you go, man. Sorry.
Okay,
I reckon this is going to be some redundant explanation that's just clearly.
But does downwardly bending light make something appear higher than it is?
Sure.
Yes. Okay. So I don't need to do this. All right. So downwardly bending light.
No, you definitely don't need to do that, dude. I understand refraction.
Okay.
Dude, I did a whole assessment on it through my university course.
Nice.
I've played a lot with light and cubes, and I've considered and thought about light quite a bit. Especially, I started freaking out when I was like, "You say that there's particles going through other like solid material. You guys just think like your photons are particles, and they're just zipping right through. It's like the glass is just like, actually, please."
Yeah, it sounds like you studied it, definitely.
So,
dude, that's pretty crazy, bro. I don't want to get into the whole deep complex that they explain it and how they explain it, right? It's the shells, the energetic states of the electron shells there on the outside.
On an architecture course, no one was talking about electron shells to you. Don't lie.
No, it's what we were taught. We were studying glass and the properties of glass, so I went in depth into we had to come up with a cool design product, right? That played with light that we could install into our building. So we that was like a whole friggin' semester worth of assessment.
And don't pretend they were talking about the physics of electrons and visibly permeable materials in doing that. That's a lie.
I went looking into it. I went looking into it myself because I wanted to impart some of these aspects.
Well, that's not them teaching it to you, is it?
No, because that's the reason that the course is so cool, man, because it's autodidactic. You can go learn what you want to learn.
Yeah,
I don't need to
that's
be
a
told
phrase
what to
used
do.
often.
They gave me a brief to go learn, okay, how can you reuse glass, right?
Yep.
And its properties to make a cool product design.
It's transparent and it has refraction, and that's as far as it would have gone for you. Don't pretend that an architecture course you went and
So I need to be told.
you looked at quantum mechanics of refraction and or electron shells and visible permeability of materials. You're lying.
No, I'm not lying. Okay, there
You
may
are. We
be
can
sort of
tell
like,
you are.
okay, if you continue to interrupt me, man, I'm just going to mute you and move on, okay? I'm not lying. There may be a third level higher than what I understand as far as some new principle of quantum physics gobbledygook, okay, that maybe I don't get my head around and wasn't exposed to. But I did go pretty in depth into the properties of it, dude. So I'd appreciate it if you just don't make these assumptions. Perhaps the way that I'm referring to it is not the way that you're thinking of it, okay? Would you give me that?
Do you remember
Would you give
any
me
of the
that?
information? Do you remember much of the information you learned about? If you went to glass, what's the refractive index range of normal glass?
Are you looking for the degree of refraction?
Thought as much. No, the index. So you don't even know what a refractive index is, and you just in degrees. This is the trouble.
Who
You don't
is
know what
this?
a refractive
Hazza.
index is, do
Hazza.
you?
What's up with you, man? I hear Venus is
Well, because
playing her
this
and
is what
pickling with
I'm
people's
tired of
brains,
people
bro.
just fibbing to me. I asked you for a refractive index, and you said what in degrees. You don't even know what an index is, do you? It
Dude.
doesn't have
Okay,
any
Pazza.
units in
Man,
degrees, is it? An index?
dude, what is stuck up your ass at the moment, bro?
People
I've
lying
already explained
online
myself.
people coming into a room
Dude,
and
if you call me a
pretending they
liar, no,
understand
I already said
refraction,
this, so
and they don't know.
fuck it,
And when they
bro.
ask for a refractive index range, they say what in
Nah, man, I'm
degree.
not copping the lying claim,
Everybody
okay?
listening
I'm
who
over it.
understands it knows how
Someone else can unmute
ridiculous
you.
that
I
response
said I
was.
was already getting ready to put it down, okay?
Yeah, yeah. Of
Isn't
course
that
you are.
something to do with Snell's law or something, Pez, or is that something different?
He's not going to
Snell's
be able
law.
to reply until someone else unmutes him.
That's how fast slimy
He's not
insects
He
move
is
muted
across
yet,
the
Rick.
unmuted.
ground,
It's
isn't
not
it?
like
Something
he's
to do with
server
like that.
muted.
Snell's
It's
law.
not muted yet.
Yeah. Something to do with how much. What is? It's the ratio of shell to slimy bit. At one end you got now, and it's 0.0.
I just remember Snell.
Yeah.
That's the only thing I remember.
Yeah. Is Rick still up for a chat? Or is he making dinner? Dinner. Anyway, I can talk into the void if Rick is listening. Anyway, so I didn't have to go through the whole light bending down makes objects appear higher than they are geometrically. That's cool. So the typical atmosphere is structured such that it's more dense at the surface, less dense higher up. This causes downward bending of light. That's our typical light bending direction. So when I am on a mountain looking across at another mountain with the same elevation, right? When I see that mountain below my crosshairs, below horizontal, when I already know that apparent position is higher than it geometrically is, that tells me the geometric position is even further below where I see it. Welcome to the globe. What the hell, Duffy? What are you talking? What you talking about, Duffy? Been some interesting chat this afternoon, I have to say.
Which one was that?
Which what? What the chat was, that's a bit weird. There were several people in the chat saying that smacking a kid on the bottom as punishment is a sexual act. Yeah, I'm out if that's the topic of conversation.
Yeah, I'm gonna just dodge that one.
Yes. Still roasting left lane. Yeah, I heard a little bit about that. What's the GO? Anyway, can I share my my other screen? One sec. You guys are gonna love this. You guys are gonna love it. There we go. So this is me, simply off a throwaway statement by Taylor last night. She said the guy that translated the Sidor paper, the Sidor refraction paper, is just some random guy, and you can't trust it. So obviously, what I did is go and do the whole thing myself, replicate it myself. Fun. Because, let me stick it in there, hold on. Because in the Sidor paper, yoink, that's in the Sidor paper.
Be out of light, be out of light. Celestine, be out of light, out of light. From Dr. Mike, GG, let's line of sight, push the line of sight, out of sight, out of sight, out of sight, look to the right, just to the right, and find a star, set a star, it's almost not, or it's back with the star side to side, just to the right, it's to the right, of the peak, a mountain peak, any mountain peak, record the time, get the time when you can't see the star at night, moving from the right, and a cold and out of sight, occluded from the right, out of sight, no refraction, there's no refraction, it can't refract none, no refraction, no refraction, son, when you can't see none, you can't see some, and you don't see none, son, so now you trigger, that's trigonometry, triangulation, it's flat line, this is baseline, now you're baseline, now you're based. The Goremon, deriving with the theorem. The Goremon, remember on the theorem with his name. Now get the true star position from the almanac. It's in the almanac, compare the angles, the baseline angle to the angle from the peak, to right where and when the star's unseen. And what do you know? Both the angles will match. The angles will show that the angles do match. From your baseline angle to the star, and the baseline to the star angle from the peak. It's a triangle, a flat straight triangle, a flat earth triangle with an extended line of sight. So go figure, wiggle. Now you trigger, trigger, dropped. Yeah, you trigger, trigger, dropped. Hey y'all, check out my giant telescope. I know it's bigger than you hope, but look, it stretches all the way up to the peak. It's just a straight line, a perfect straight line to a star we cannot see. Just when the stars just can't be seen, turn off refraction, subtraction. That's just the stars that you still see, only for stars that can't be seen. And even then, son, the claim refraction, it's only how they make it seem. It's how they trick the ball below your feet, but there ain't no ball below our feet. It's just a practice of deceit. You see, refraction equals ball below your feet. A tricky treat, tricking you with stars you see. So thanks, Dr. Mike, drop the dynamite. G.